up to us will talk about tire stems. And it's kind of a niche RF frequency to look for things. And I'll get into that a little bit when hopefully my presentation comes up. There is a box of kittens and interesting things, the proofs of concept that go along with this. And if you have some interest, we can catch up after the presentation over lunchtime or in the chill room. And when we do get some internet connectivity and more than just the parrot logo, there's two Git presences if you want the deck I have and any of the proof of concepts, the Arduino sketches, Python, and some of the naughtier stuff. That's all out there. You just have to look it up and you can pull the repo. I never restart this. You're just not supposed to restart Linux. This is, there you go. Okay, we're doing something. You see the stickers, they make it go faster. Well, you know, I'm old like it is. All right. Visual aids. I meant to wear this. This is the albatross I wear around my neck. This is my first lovely Hack RF. And it worked for me great. It was one of my favorite toys. I played with it every day. And what I did wrong, somebody at some point in my life, they told me if you leave your toys in the driveway, they're going to get run over. Don't be me. Now this is just one. I got a whole necklace of stuff. And I'll caution you a little later about voltage when we get a presentation. We're almost there. If you put the wrong voltage through your little RF module, it'll be garbage, and you can wear it on your neck like an albatross at a different presentation. Broken laptop. I'll warn you about this in the presentation. I mentioned it, I'm cheap ass. Any minute now we'll get a Linux operating system here somewhere. I'll give you a little history that's not in the slide presentation. This whole idea started with guys like Dragorn and Dr. Russ. A lot of the inspiration of this was from just a chat at a bar that was kind of like, wow, could you do this? It's like, well, no, not really. It would be terrible. But why don't we try anyway? And some years later, I had the opportunity to do some pen test and some physical audit for an auto shop. So I'm there looking at the normal kind of stuff, but I'm also kind of, I have some RF tools, and I'm looking around, I was like, wow, this is kind of interesting. There's something going on here. So let me actually get a presentation going for you. And I'll explain more. The tire shop has all these tires stacked up in the back room. And if you listen to RF on a couple different frequencies, what you'll see is it's really noisy. It's like, wow, there's a whole bunch of devices in here. What the hell is that? And what it really is these stupid little tire stems. I'm getting ahead of my presentation, waiting for it to load up. Technically, I'm only 2 minutes in. This is what happens when the demo gods get you. You just commit seppuku on stage. All right. Well, yeah, seppuku, you need witnesses. Witness the honor. One more time. All right. This would have been easier if I just told you to open up the GitHub repository. Now we're cooking. So let's see. Is that okay? Yeah, good. That works just the way we want it to. Stanley. So everything starts with Stan. All my slide presentations, he goes in there first. And if you don't know the line, it's, you know, with great power comes great responsibility. This particular demo doesn't go too far off the rails into doing bad stuff, but towards the end, we get into some things that'll get you into trouble. And I'm not saying anything from a law perspective. I'm not a lawyer. I don't even know one. But I will tell you, if you point a Yagi antenna at somebody who's driving by your house, they're going to ask questions about what the hell you're doing. And you're not going to make friends that way. Big disclaimer, right up at the top. I said before, I wouldn't be here talking to you if it wasn't for guys like Dr. Russ and Draghorn, and in particular, the Kismet project. My space in this is kind of niche. If you just want to see some signals and you want to look at something today, install and set up Kismet. I'll put two things in after that, stuff I've learned from Kismet. Number one, you can't store all the stuff. If you want to record signals, you can catch so much and then you're going to run out of space. You got to kind of calculate where you're going to put it and what kind of metadata you want to pull. So later on, when we get into my use cases, the metadata will be the important thing. I just captured just a little bit. I'm not trying to capture everything. Number two, warning, learn from Kismet, is if you want to mess with SDR, pick a good operating system or a good flavor to go with SDR. Pen testing rig like my old Parrot machine, not the best for really good SDR dissection. If you want to do that, there's good stuff in the repo. You can pull to a better distro, and you can get into the SDR and the hack RF stuff a little bit more deeply than I'm going to do with my demo. I mentioned permission. Assume you're going to break it. Even if you're evil, you know, assume that you're going to be on somebody's radar maybe when you're broadcasting. We'll get into the length of the tire pressure RF in a little bit, but you can spoof it at a much higher broadcast, and you can actually interfere with other signals because you're in the same bandwidth as other stuff talks in. Please don't wait to the end. If you have questions, just speak up. Most of you are not shy, and the ones that I know definitely aren't. So if anything strikes your interest, please say so when we get to it. I'm supposed to. There you go. A couple things first to add to that. I kind of went into the legal notes and then read aloud in the Vegas voice part. Do not perform RF transmissions inside on your neighbors or anywhere you're going to be obvious. Don't point a Yagi antenna at your neighbor. Do not interact with unconsenting vehicles or environments. Most of my proof of concepts are harmless. They're listeners, very quiet, very passive, and they don't interact. At the point that you are on your lawn with a line of Yagi antennas, you're a little more interactive. And if you spoof any of this, you're very interactive. Careful of local regulations. The 415, actually 433 is a band that's shared by other stuff, including police radar, Wi-Fi, Bluetooth. So if you are broadcasting, you're right in the middle of that. And if you're listening, you also have all that interference that you've got to figure out how to sort out. So local regulations, you need to watch if your broadcast bandwidth is getting wider than tire pressure monitoring, which is almost the touch length. Bottom of that, if you can see it, if you really want to open up either of the repositories, all the code and stuff is in there. Confessions. I'm lazy and cheap. So I have an ancient laptop that took forever to start up. Hack RF is a great tool, but it's also the albatross. You don't want to replace a Hack RF. You don't want to leave it in your driveway. You don't want to leave it out in the rain. Unless you're taking it out and physically pointing it at a tire, it's probably not the best choice if this is really your project. I lament breaking my small, expensive, fragile toys. Please don't be me. Antenna theory. I'm not your guy. But if you just want to pick up some tire signals, any little butt plug RF antenna will do. It doesn't really matter. You're going to be basically right up on top of the tires that you're going to be monitoring. If your proof of concept or use case expands from that, what you probably want is a Yagi antenna. And the Yagi antenna should be tuned to the frequency that you're looking at, so 433, 315, or some of the higher bands depending on model. And if you really want to catch everything going by, you need both. And if it's going by at 50 miles an hour, you need a nice array. You can't do that with a hack RF unless you've got good cash going on or somebody to support it for you. Last warning, everything in this is written by AI. I confess, everything in here was at one point copy-pasted from something. If you want more on getting naughty code from AI, come see PumpCon fail in 2 weeks. All right, now this is the Steve at the auto shop guy stuff. Why tire pressure monitors are present? So back in the 1990s to Y2K, several different governments decided that carbon emissions would be reduced, safety increased, and just the wear and tear on things if they monitored the pressure in the tires somehow. The catch, there was no how to do it. They just said you have to do it. The U.S. Dread Act, if you want more specifics, that's the one to look up. It's just a light framing that there must be some way to tell the driver if there's an underinflation. I'll get into a little bit more specifics on that, but we were only focusing on one specific kind of beacon of the tire pressure. Japan followed suit. That also means that other manufacturers in other countries just started right out of the chute with tire pressure monitoring built into the car, which means the tires should match. And purpose, less CO2 emissions, and safety because the tires are fully inflated and monitored. So what's happening inside the tires? That's probably a tiny little screenshot for you, but inside of any of the tires that are manufactured to this standard, there's this nice little device. It's meant to last for 8 to 10 years. The lithium-ion battery is actually baked right into it. Nothing is meant to be replaced, and it should last for the life of the tire 8 years on its battery without ever being taken out. The 2 flavors. So I mentioned that everybody has to have at least one way to monitor their tire pressure. What we care about is the first one, direct TPMS. That means that the tire itself is beaconing information and the car is supposed to pick it up on a receiver. The second one is based on inertia and has a little bit to do with anti-lock. And it has to do with how efficiently the tires on each side spin, and it compares it based on math. We don't care about that because it's not RF. This is part of why TPMS isn't really an adequate sensor for an entire spectrum of monitoring, because you're going to miss stuff. Any car that was made before 2010 or 2008 might not have it at all. Any car that uses the alternate technique doesn't have the right kind of stem. What I will say, anecdotally and from the tire shop guys, is that luxury cars tend to have the radio frequency, TPMS, and it also tends to beacon really loud, really often, and it also has usually some interactivity, so you can actually prompt it and ask a question and it responds back. Sleep and power cycle. Because you want the battery life of the lithium-ion battery to be the life of the tire, the clever thing it does is they'll sleep. So if you're an auto shop and you put them up on the shelf and they sit there for a year, they stop beaconing so that they can conserve their energy. And what the auto shop guys could do is they just go by with a magnet and the magnet reactivates it. Same thing will work on a tire in your driveway. If it's not beaconing, the magnet should activate the TPMS even if it's getting kind of tired. The other thing that will activate it is inertia. So you take it out and you bounce it around a little, put it on a car, and it'll start to beacon again. They do beacon even after the car stops moving. So overnight, the car sits in the driveway and all 4 tires continue to beacon every couple seconds or every couple microseconds. Strength and complexity. This is real important. The tires, they're not meant to beacon like Bluetooth or Wi-Fi. This room is full of Wi-Fi signals right now. You wouldn't hear my tire stems over in the box because there's so much overlay on that. And you probably aren't going to get to 20 meters. 20 meters, we're talking a luxury car that's beaconing really loud. And the reason I mention luxury cars is the tire life expectancy on a luxury car is shorter. The tires are better, but they're going to get changed. So they beacon loud, and they tell you when your luxury car tire is worn out, so you replace it sooner. Packet encoding. This is worth a quiet mention. If your interest is something more specific than just the IDs that are associated with the radios, then you can look up the specific brand, and if you dissect the RF signal that you're getting, it'll be more specific to the car, and that's where I say you can tune that in, so if you want to know something about your Ford and the tire inflation, it'll probably tell you more. Chips and dips. So I didn't make a lot of diagrams for this. There's some generalities. I've used Arduino Uno and Arduino Uno clones. Really important is my CC1101 RF transceiver, which I will say wrong at least one. I'll just say it's an RF transceiver and you just know what I mean. And then lots and lots of ESP32s. They're cheap. I can run over a couple of ESP32s before I get really upset about it. So the ESP32s in particular replace the hack RF. You add the little RF module onto the ESP32, and now you've got a listening agent. And if you're really good at it, you could probably connect that listening agent into Kismet and have just one central amalgamation of all the RF signals in your area. And somewhere there was a fellow who did a talk yesterday with a big orange box who was right up on top of this. So you marry the RF signals and listening agents of this project to his masterpiece, and now you can listen to the car tire stems too. Last warnings, and the next slide is a warning too. I have a diagram that's about right, but your mileage will vary. Little Satan, lots of good diagrams like this. Be careful when you order from Amazon. You're probably going to have to look something up. Your RF module might not have the same number of pins. This is a rough map that covers all of my proofs of concept one way or another. And an important side note on the CC1101 pin column, if you pass too much voltage to it, it will fry the chip. If you work with ESP32 cameras, the first thing you want to do is turn the voltage up, because you want to run the camera, you want to run it at 5 volts. If you repurpose one of them, like I did, it'll cook your chip. So this is meant to be a general guide. Any of these things should work. ESP32s are essentially Arduino Uno clones anyway. One of the toys I have in the box there is a robot that's built on that frame. And if you want more information than this, it's really going to depend on the chips that you have in particular. Even the ESP32s vary a little bit. Use case. So I got my auto shop shirt on here. I'm Steve. This first use case, and this is what you can do with the hack RF really simply without having any of the extra electronics. All that the auto shops do is they point a device toward the tire, it picks up the receiver, and the advantage of the device is it has a library of the manufacturer's code, so it knows how to interact with that as much as it can. And it basically gets the same information. The tire beacons back, it's inflated properly. The tire beacons back a different pattern, it's not inflated properly. This use case, you could implement this yourself. You could use this to just check your own tires if you wanted to look through the information up. The basic idea is just picking up a real weak signal. If you wanted to capture this, and I'm kind of leading later slides, the data output, if you're capturing it perpetually, so you set your hack RF out in the driveway like I told you not to, and you listen overnight, you need to timestamp what you're gathering. So Kismet is a good choice because it's already doing it. The Python code samples that are in the GitHub repository do it too. They'll pick up the agent that's listening and give it a unique ID, and they'll give you a timestamp, and then they give you the tire IDs that it sees. So you have, between the three, a unique key, and you know that there's no duplication. Distributed listeners. This is probably the key. This is my best proof of concept. If you have multiple ESP32s with their RF cards and a variety of Yagi antennas pointed down angle toward tires, you will catch cars that are going by on the street. And you can aggregate that, and you can make a map of everybody who's gone by your house in the course of time. If you wanted to use this for practical applications, you could do this at a gate, and you can track fleet vehicles as they leave the premises and track them when they come back on. You know, all the vehicles are on premise based on 4 points of information that you gather as it comes through the gate. Gates are great. Cars have to stop at gates. You don't need a great big Yagi antenna because you know where the tires are going to be, and they're going to sit there for a minute. You could also use this sort of thing for a garage door opener. If you had two cars, you map their IDs of their 4 tires, and when those 4 tires are present near the sensor, open the garage door. A little bit on output. I didn't put much of the code in the presentation as slides because it's in the GitHub repository, and if you're really interested, that's what you want anyway. The one side is the MySQL database that has just the samples of some tires. And they are actual random ones, as opposed to fiction. The magic of that particular part, the Python listener, isn't really that complex. It's basically just receiving the information from the agents that are out in the driveway listening and putting it into a database, and then it's serving it up with a nice Flask interface so I can see what it's doing. This is where you would map this project into Kismet, or I wish I remembered the fellow's name from yesterday. Yes, no, you're right there. I was looking for your orange box. Him, this guy right here. This project maps, this part goes right over to the kind of thing he was talking about where you get entire perimeter surveillance. And since I mentioned that, because TPMS is not reliable, you probably want something more like a brake beam or his stuff because it's listening to things that are always on and always making noise. But this one could supplement that idea. I started mentioning the gates and garage signals. This is a better use case than actually putting something out beside the street and trying to catch the ambient signals, because you know you've got somebody coming up a fixed driveway, you know you've got them stopping at a specific point, and you know you can let them in. You can also say, I don't know you, and keep the gate closed. So it's not just like a pressure sensor where somebody pulls up and then the gate opens real slow. You can actually deny entry this way. And much of this is repetition. The same cards are in use, and just how specific you need it. You multiply the ESP32s and CC1101s. That's you can get all 4 tires. You can get multiple gates. You can amalgamate this all in one place. This is the most complex use case that I have that's tested and works. So if you know the vehicle path, side of the road, you can set up the array. And I sort of described this while I was waiting for things to start up. If you have multiple listening agents set alongside of the road with a variety of Yagi antennas pointed down at about 45-degree angle, it's going to hit most of the tires that go by. You've got about 5 meters on any given tire. So from the side of the road to the middle of the lane, that's entirely achievable. And as long as you have a variety of antennas and an amalgamator, you can catch all the traffic that goes by. And once it's in a database, you can now decide friend or foe and unknown, or alert me. So if there's somebody you not only don't want in your driveway, you want to have it send you an alert, well, that's real easy. That's just a little Python side routine to have it send you an email or send you a text saying so-and-so is in my driveway, you call the police. I kind of explained this one the slide-wise. Thresholds are bad. Human in the loop for classification is needed. I'm jumping all the way down to my bottom bullet point. The classification, good and suspicious, that's a human step. Once it's in your database, that's real easy. You could do something like telling the listener only alert on Fords or only alert on Teslas, because all these radios have a unique ID that's kind of like a BSS ID or your Wi-Fi ID. It's exactly the same number of characters. It fits in a database with everything else. It's the same basic idea. It uniquely identifies each radio. And so, safety notes and considerations for projects. I've outlined 4 different use cases so far, and most of these are pretty safe. The one thing that I've mentioned, that if you're really interested in RF sensing as opposed to just picking up some signal, you really want some timestamp. And if you want, you need to separate the listening agents in space so that you know that the vehicle is at one point and then the vehicle is at another. So you might want to tie GPS into that if you've got a long driveway or you're back in the woods somewhere. Battery life cycle. The nodes may go to sleep and they may also be dead. So if you're trying to experiment with something at home and it's not beaconing, wave a magnet around it, shake it a lot, throw it at the floor, maybe look for another flat tire. I mentioned antenna choices, small whip, little butt plug antenna for just walking right up to a vehicle. Yagi is really the one for larger antennas. Talk to somebody who really knows this stuff well, and they'll tell you how to measure the Yagi and have the driven elements in the proper distance to pick up the frequency you want. But the little RF cards, they'll take absolutely any antenna that you want as long as you strip off a coaxial cable and connect it. So it's real easy to go from a $3 RF card to a pretty good listening device. Pinout and wiring cautions. I wish I could have done a better drawing for you, but no 2 proof of concepts are the same in the actual onboard chips. So I can't even compare one ESP to another because I have two different ESPs and they don't match. The CC111 or CC1101s are pretty similar, but they don't all come with the same number of pins. There's a couple that I have that you just ignore 2 of the pins. You could cut them off and nothing would misfire on this. And then there's others I have that don't have them. So you really want to check your pin out and you want to make sure that you've got everything straightened out. And then really important is that 3 volt for the RF cards. Make sure that you're operating at the right voltage. Otherwise, you're going to cook things before you even get to try them out. Do not transmit or replay. So once you have all these IDs in a database, you can play that back. And within the GitHub repositories, there is a Python script that will take the MySQL database and basically replay all the cars that went by in the course of a day. Now, for RF, that's harmless. So what the heck does that mean? But to a system that was monitoring that would be atrocious. You would pack a database with absolute nonsense signal, and you could randomize it. I'm not suggesting you do that. I'm saying don't do that. Just for the record. I made that sound attractive. Regulatory permission. Because the spoofs don't use the real simple technology that's inside of the TPMS, the broadcast can be much, much louder. And I think I said this rambling before things started up. You can out-broadcast tires. You could actually spoof a tire that's in your driveway using Python in the house, because the one in the house has a much better radio and is a much louder broadcast, and it's just sending the same information. So you could tell the car it has a flat tire, or you could tell the car the tire is inflated when it's flat. All right, this is the no more go away slide. So basically, this is the end of the clean part of the presentation. And